Hello student, today I am going to discuss some additional information about equilibrium. Actually in equilibrium one equation is there that is not left out, it is not in your syllabus, but question is asked. That is the Henderson-Hasselbalch equation. Henderson-Hasselbalch BALCH equation. Henderson-Balch equation. Then this equation is important for your examination, or in competitive examination numericals they are asking based on this Henderson-Hasselbalch equation. Or in indirect way you can say preparation of acidic buffer. Preparation of acidic buffer. On the basis of this equation, actually acidic buffer or basic buffer is prepared. Then now I am going to discuss this. Also it is known as designing buffer solution. Designing buffer solution. Then here we know knowledge of pKa, pKb and equilibrium constant. Three things. Knowledge of pKa, pKb and equilibrium constant help us to prepare the buffer solution of known pH. Okay, of known pH. Now how we can say it can be made? Now I am telling. Preparation of acidic buffer. To prepare a buffer of acidic pH, we use weak acid and salt on its salt, and salt of weak acid. Salt of weak acid, okay, formed with a strong base, because for the formation of salt acid and base both are required. Then here weak acid you are going to use and its salt means salt of weak acid. This acid formed from a strong base means acid is weak and base is strong, then its salt. Two things you are here taking, weak acid and its salt with a strong base. Okay, we can develop means we can derive, we can develop the equation relating three things. What are that three things? pH, first things. Second things, Ka means equilibrium constant of or dissociation constant of acid. And third things, ratio of concentration of weak acid and its conjugate base. Ratio of concentration of weak acid and its conjugate base. These three things you will correlate. You will relate three things: pH, pKa and ratio of concentration of weak acid and its conjugate base. Now derivation is easy. For general case, wherever the weak acid means Ha, H means hydrogen ion, A means anion, A negative. Okay, then Ha will dissociate, Ha will ionize. You know that in water, Ha will ionize, it will ionize like this Ha plus H2O. It will give hydronium ion plus anion means A minus. Then Ka, what will be the Ka of this equation? Then Ka will be same way concentration of products divided by concentration of reactant, means Ka is equal to molar concentration of hydronium ion into molar concentration of anion divided by molar concentration of Ha means acid. This is the Ka. Now we can rearrange this equation. Our intention is to get the value of hydronium ion, which is left side. K is equal to molar concentration of hydronium ion into molar concentration of anion divided by Ha, molar concentration of Ha. We want the value of H3O, means hydronium ion. Just we have to do cross multiplication. Then you will get the value of H3O. Then molar concentration of H3O after cross multiplication means rearranging the expression. We will get H3O is equal to Ka into Ha divided by A minus. After rearranging means after cross multiplication, you will get molar concentration of hydronium ion is equal to Ka into Ha divided by A minus. After that, what you have to do, you take logarithm. You take logarithm both side, minus log you can take both side. Then H3O will become minus log H3O. Minus log H3O. Then H3O means H ion. Then minus log H3O means left side minus log H3O. Means you are talking about the minus log H ion. Minus log H ion concentration. And that is pH. Minus log hydrogen ion concentration, that is equal to pH. Now right side is two term, Ka and ratio of Ha and A minus means anion. Then now we are taking minus log for both. Then what will become? Minus log K, that is a log x into log y. Log x into y is equal to log x plus log y. And that formula you will use here. Here Ka into Ha divided by anion is there. Then minus log you will take. Then you will get minus log Ka. Minus log Ka. Then minus log Ka you can write Pk. You can write minus log means P. Then minus log Ka means pKa. Okay, pKa. Minus log Ka means pKa. Then now come to the Ha ratio. Then ratio minus log you are taking minus log Ha divided by A means ratio. Then this also you have taken log, minus log. Okay. Then now this you got pH. You got pH, that is equal to pKa minus log and because you have taken minus log for everywhere, then for minus log H3O, for that you have made pH, and minus log K you have written pKa, and after that actually this for ratio it will be also minus log Ha divided by A. But if you will reverse it, when you will reverse this ratio, if you will reverse it, then minus will become plus. Minus will become plus. Means in the Ha divided by A minus was there, means anion. Now you are reversing. Then minus will become plus log. Minus log will become plus log. And A will go upside, Ha will come down. Means you will get, final result you will get pH is equal to pKa plus log molar concentration of anion divided by molar concentration of HA, means acid. Then here finally you are getting pH is equal to pKa plus log conjugate base molar concentration of conjugate base of the acid HA. HA was the acid, then its base will be A minus, means anion. Then now you can say pH is equal to pKa plus log conjugate base anion divided by molar concentration of HA. This equation actually is known as Henderson-Hasselbalch equation. Henderson-Hasselbalch equation. This is very, very important relation. Okay, this comes under the actually this pH, pK you have studied only in equilibrium chapter in acid base. Okay, then this you got important relation pH is equal to pKa plus log concentration of molar concentration conjugate base molar concentration of conjugate base, that is the anion, divided by molar concentration of acid. This is the Henderson-Hasselbalch equation. And here one important thing that if concentration of conjugate base and concentration of acid, if both will become equal, conjugate base and acid, if both will have same concentration, then what will happen? Upside and down both become same, then it will be cancelled out. Both will be cancelled out if both concentrations are same, conjugate base and acid. Suppose both have same concentration, then both will cancelled out. Then you will get log 1. Log 1 is equal to 0. It means you will get pH is equal to pKa. pH is equal to pKa. What is the condition? Then condition applies here that concentration of conjugate base must be equal to HA, means acid. Conjugate base of acid must be equal to the HA, means acid, weak acid. Then in that situation, pH will be equal to pKa. Okay, this is the important things, how both will become equal. Then this is the condition I have told you. Okay, means you can tell the quantity anion divided by HA is the ratio of concentration of conjugate base, means anion, of the acid and the acid present in mixture. Conjugate base of the acid, correct, divided by acid present in the mixture. This is actually ratio. Since acid is a weak acid, it ionizes to a very little extent, and concentration of HA is negligibly different from concentration of acid. Both will be almost equal. Okay, weak acid, it ionizes to a very little extent, and concentration of HA, means acid, is negligibly different from concentration of acid taken to form buffer. Then here both becomes equal. Also, most of the conjugate base anion, and again anion mainly it is coming from the salt formed. You have taken acid and base, a strong base and weak acid, then weak acid and a strong base, it formed salt. Then in that anion will be there. Anion will be there. Then that is actually an ion. Plus from the acid also it is giving anion, but it is very, very less. But mainly anion is coming from the, you can say, salt, which was formed by weak acid and a strong base. Then main, you can say, anion is from the, you can say, salt. From the, you can say, salt, main anion is coming. Okay. And then you have understood how, you can say, conjugate base means anion is coming. Anion comes from the ionization of salt of the acid. Okay. Therefore, the concentration of conjugate base will be negligibly different from the concentration of salt. Main is the, it is coming mainly from the salt. Hence, both will be equal. Means concentration of salt and concentration of acid, both will be almost equal. Then this ratio will become 1 because both are almost equal. Hence, this log concentration of salt divided by concentration of acid. In the place of anion, you have written concentration of salt because anion concentration and salt concentration is almost equal. Hence, in the place of anion, you have written concentration of salt. Then Henderson equation is also written like this: pH is equal to pKa plus log molar concentration of salt divided by molar concentration of acid. Henderson-Hasselbalch equation is also known like this way. In the place of an ion, you can salt, you can write. Okay, down already acid is there. Then pH is equal to pKa plus log molar concentration of salt divided by molar concentration of acid. This is also known as Henderson-Hasselbalch equation. But in this equation, because molar concentration of salt and acid becomes equal, hence this term will be, this ratio will become 1 and log 1 is equal to 0. Hence in this situation, pH is equal to pKa. Okay. In the equation, this equation I am talking about, if the concentration of anion is equal to the concentration of HA, anion is equal to the concentration of HA, then pH is equal to pKa because value of log 1 is 0. Value of log 1 is 0. Thus, if we take molar concentration of acid and salt, means conjugate base of the same acid, the pH of the buffer solution will be equal to the pK of the acid. This is important things. Okay. pH of the buffer solution will be equal to the pK of the acid. So the preparing the buffer solution of the required pH, whatever you want pH, for that pH, then if you want to make a buffer solution, then here buffer solution of known pH, if you want, then preparing the buffer solution of the required pH, we select the acid whose pK is closer to the required pH. Okay, we select the acid, that type of acid we have to select whose pK value is close to the required pH of the buffer solution formed by the acetic acid and sodium acetate taken. Then if you want to make, as for example I am telling you that you want such type of pH, you select pH, we select that acid. We actually this solution will be equal to the pK of the acid, I told you. So for preparing the buffer solution of the required pH, we select that acid whose pK is close to the required pH. As for example, for acetic acid, pK value is 4.76. For acetic acid, pKa value is 4.76. 6 already I have told you in last class. For acetic acid, pK value is 4.76. Therefore, pH of the buffer solution formed by acetic acid and sodium acetate taken is taken in equal molar concentration. Both you have to take in equal molar concentration. Acetic acid pK value we are knowing 4.76. Therefore, pH of the buffer solution formed by the acetic acid and sodium acetate taken in equal molar concentration. Okay, this is important. Both you have to take in equal molar concentration will be around 4.76. pH of the buffer solution will be 4.76. Okay, if acetic acid and sodium acetate you will mix in a equal concentration, equal molar concentration. Same way you can derive, you can say this for basic buffer. A similar analysis of a buffer made with a big base and its conjugate acid. I told you for the acid conjugate base and for the base conjugate acid, reverse. Then a similar analysis of a buffer made with a big base and conjugate acid leads to the result. Same result you will get. That is the POH is equal to pKb plus log conjugate acid, molar concentration of conjugate acid divided by base. What you got earlier, reverse way, that was for acid. Salt was up. That means there anion was there. In the first case, anion was there. Means it was the conjugate base, anion. Now here you will get conjugate acid. Conjugate acid. Okay, means BH you can tell. B means base. Conjugate acid and conjugate acid of base. Conjugate acid of base BH. Then down will be base. Down will be base B and its acid will be conjugate acid will be BH plus. That will be upside. Then now you got POH is equal to pKb plus log molar concentration of conjugate acid, that is the BH plus divided by base B, capital B. Okay, this is again called Henderson-Hasselbalch equation. Here again you can say same concept. If you can say ratio conjugate acid and base, ratio of conjugate acid and base is equal to 1, becomes equal to 1, then this term will become 1, hence log 1 is equal to 0. In that equation you will get. In that situation, when both becomes equal, concentration of conjugate acid and base become equal, that time POH is equal to pKb. Then this situation will come in the same way what I have discussed. Okay. in the case of pH. Okay, pH of the buffer solution. pH of the buffer solution can be calculated by using the equation. How? Then you know pH plus pOH is equal to 14. This is a relation. If anyone you are knowing pH or pOH, if anyone you are knowing, then total is equal to 14. And suppose if you are knowing the pH, then pOH is equal to pOH value will be 14 minus pH. Or if you want to calculate pH, then 14 minus pOH. Hence this formula is also very important. pH plus pOH is equal to 14. Already I have discussed. Okay, we know that pH plus pOH is equal to pKw. This also we know, this relation. Two relation is there. pKw is equal to 14, you know. Then you can write in any way, pH plus pOH is equal to 14 or pH plus pOH is equal to pKw. And pKa plus pKb is equal to pKw. That also you can write in the place of pH and in the place of pOH. You can write pKa plus pKb, that is equal to pKw. Then three relation you got. pH plus pOH is equal to 14, pH plus pOH is equal to pKw, and again for the pH you have written pKa, and for the pOH you have written pKb. Then pKa plus pKb, that is equal to pKw. Okay, on putting these values in equation, actually what we derived equation, that is the now we have for pOH we have derived the equation. Then this value means pKa plus pKb, that is a pKw. These three relation I have told you, na? Then this pKa plus pKb, that is equal to pKw. This value, if we will put in the pOH, that is equal to pKw plus long conjugate molar concentration of conjugate acid divided by base. There if you will put, then you will get a new relation. Then what you will get? You will get actually pOH is there. pOH. Then pOH is equal to what? pOH value means you know that pOH is equal to now pKw minus pH. You can write pH plus pOH is equal to pKw. Then for the pOH, in this Henderson equation you want to put the value of pOH. Then pOH is equal to pKw minus pH. That value you put in the place of pOH. Then now Henderson equation will become pKw minus pH. In the place of pOH you have written pKw minus pH. That is equal to pKb. That is equal to pKb. Okay, pKb plus log and you can say ratio of conjugate acid divided by base. Then now for pKb again you write the value. Again just like pOH, in this for this Henderson equation you have written the value of pOH. Now same way for pKb also you can write the value. Then for pKb what will be the value? Then you know that pKa plus pKb, that is equal to pKw. Then pKb is equal to what? pKw minus pK. You have written three equation here. Then all three relation has you are going to use here. That's why you have written here. Okay. Then pOH value you have written. pOH value you have written. pOH is equal to pKa minus pH. For the first term you have written in Henderson equation. That is equal to pKb. Then pKb is equal to now pKw minus pKa. Then now you have written the two value. Value for pOH and value of pKb you have written. And third ratio you keep as it is. And third term you keep as it is. Means log concentration of conjugate acid divided by base. You write same way. Okay. Then you got actually new relation. You will get new relation. Okay. Because pKw and pKw will be cancelled out. After you have put the value, after that you will see pKw, one is in left side, other in the right side. Hence both will be cancelled out. Then you will get the relation. What relation you will get? Then you will get the relation. Actually after cancelling you will get minus pH. Left side minus pH will remain, and right side you can say minus pK will remain, and third term, that is the plus. Then now if you will cancel the minus, or you can do also cancel the minus, then minus pH minus pKa minus a plus log was there, then minus will cancel and plus will become actually minus pH. Minus pH will remain. pKw will cancelled out, then minus pH will remain. Okay, and other will remain minus pKa. Minus pKa will remain. Okay, then now if both will cancelled out, then minus pH and minus pK, minus value will cancelled. Okay, finally you will get pH is equal to pKw. pKw will get plus log conjugate. You will get log, that is the conjugate molar concentration of conjugate acid divided by base. Okay, you will get this. Now this I have told you, this is the new relation. pH is equal to pKa plus log conjugate acid divided by base. Okay, this is the very important relation. Then this I have told you. This I have told you about the, you can say, Henderson equation. And again here little more you can understand. Okay, if molar concentration of base and its conjugate acid is same, what I have told, again I am repeating, if molar concentration of base and its conjugate acid means cation. Okay, conjugate acid means cation. If both are same, then pH of the buffer solution will be same as pKa. pKa means pH is equal to pKa. Okay, pH is equal to pKa will be the same as pKa for the base. pKa value for ammonia, already I have told, pKa value for ammonia is 9.25. pKa value, always you should remember, this is common. pKa value of ammonia is 9.25. Therefore a buffer of pH close to 9.25 can be obtained by taking ammonia solution and ammonium chloride solution of equal molar concentration. If you will mix, then this buffer solution will be ready. Okay, again I am telling you, a buffer of pH A buffer of pH close to 9.25 can be obtained. How? By taking ammonia solution and ammonium chloride salt. Ammonia solution, that is a base, and its a salt, then ammonium chloride, because chloride is from the strong acid HCl. Then ammonia solution plus ammonium chloride, if you will mix in equal concentration, equal molar concentration, then you will get a buffer solution. Okay, buffer solution you will get formed by ammonium chloride and ammonium hydroxide equation. Okay, then here you can write that is the pH. pH is equal to 9.25. pH is equal to 9.25 plus log, same things you have to write, molar concentration of conjugate acid divided by conjugate base. Then here also, actually in the place of conjugate acid, that you can write the salt like before what I discussed. Okay, same way this is also called that was called Henderson equation. Here also you have derived that was also Henderson equation, and this is the new relation. pH is equal to 9.25 plus log molar concentration of conjugate acid divided by base. Okay, then this is the new relation you got. pH of the buffer solution is not affected, again important things, pH of the buffer solution is not affected by dilution, because ratio under the logarithmic term remains unchanged. No change, unchanged. That's why it will be the by dilution pH value will not change. Okay, and today I am stopping only here. Again next class we will meet. Okay, thank you.